Hello everybody, welcome back to some more Beltmatics, which is a belt-based mathematics game. In the last episode we did improve the multiple multiplication operation unit, and we made this condensed thing, which I'm really happy with. But the yeah, we need to utilize this to make some of the larger numbers here. For example, we do need to now make 4,566, and we did decide we wanted to go the route of making 50 times 90 and add 66 on top of that. So there are no tens in this game, which makes everything just a little bit harder. But you know what we can do? We can make tens and then put tens into these things here, and I think that is the correct application of this. So what we do is we take something like this original thing here, and we strap just another set of these guys to go into some of these initial guys here. So we need 9, 5, 10, and 10. So we do some things to become 10 into this thing, and we do some things to become 10 into this thing, and then we put a 5 and a 9 into here. And yeah, doing stuff like this is just the way we have to make do with what we got here, because the game is going to require us to make larger and larger and larger and larger numbers, and I think it's just going to be impossible without having ways to get into the tens. Now, so we do want that, and after that we also need to fit on one of these things. So let's just make a copy of this, put it over here, and then we copy up one of these things. This job is to add 66 later, so we also need 66 from someplace, and for that I think we utilize another one of these, which is multiplying a 6 and 11 together. And this unit here is supposed to be very good at making these large numbers here, which we are going to need. So let's copy this bad boy up, and then we need to find a place where we have 9s, 6, 11s, and 5s. So we probably want to go like this place. We could rotate you around like this, and yeah, a little bit annoying that we have the stream down here, but let's fit you. Let's fit you like this. Oh, there's a little bit of a mishap on the there's a little bit of a mishap on the initial thing over here. We need to demolish this part and this part. We do need this. We do need a new one of that. You need no, you're putting the output over there. Okay. Never mind. Actually, we do regret. We're gonna fit you over again. Do this, and we need to make sure you are coming in like this. Yes. Okay, that's a lot better. This is gonna be where we have our blueprints. So yeah, it was like here, like 9, 5, 2, 2, yeah, around here. So let's can we fit you over here? Yes, we can. Okay, that's great. Precisely where we want to have you. So 11, is there a 6? There's a 6 over there. Bring the 6 around like this. Of course, these 66s aren't the most important thing. No, wait! Why are you doing that again? You're doing that again. Okay. We need to just fix that then. That's probably... Yeah, okay. Easy fix, but I thought we fixed that earlier. Okay, that means we need to clear everything out of here, and now this is fine. Then we need to add the 5s and 2s we need. So one set of 2s are coming over there, one set of 2s are coming over there, and these 5s are going in here. They are going in there because we need 1 of 5, and we are going in here, and then we need a 9 like that. And this should produce the number we want, right? So we have 10s in here, should produce 90 once the 9s are getting here. This produces 50, should spit out 4,500. And it does quite prettily here, and it produces 4566, which is precisely the number we are trying to acquire here. So, and that's also the upgrade we need for more delivery speed, which is the most important thing. We are way far away over here, so let's just try to bring everything around here. Do we need this thing anymore? It produces 700. Just flat 700. Do we really need 700 anymore? Yeah, we're gonna need 700 anymore. We can't. I guess we build around this thing then. We bring it over here, down there, and into there. Okay. Did we accidentally build through? No, we didn't ruin anything. Okay, that will deliver in due time. Then it is maybe this thing's turn. It should be decently easy. We need to make 3,000, and then we need to subtract 32, which is like 4 times 8. We can maybe use the this thing again. We just need to also put on another multiplication unit before we add stuff here. So let's. I don't think we need to specifically make the design first. I think we can just copy this and build it on the spot. So for 3,000 we need I'm just trying to think of a nice clean way to make that. 15 times 20 is 300, so we need to do something a little bit more extreme than that. 60 times 200 could do it. That's like, I think we need like this thing again to make it easy. But I mean, it should be a decent way to do it. 3,000 divided by 6 is 500. 500 is like 100 times 5, yeah. 500 is 25 times 20. So it's like 6 times 5 times 5 times 5 times 4, which, yeah, I think we just need to have another layer here. And once we have that another layer, it's really easy. So 4s, 5s, and a 6 should do it. So for example, over here, 4, 5s, and a 6. And then we want subtraction units at the end here, and this is going to lock up onto the the lower end is what we want to be the larger number, like that. And then we need another one of these multiplication units, and we put it yeah, we can mess around with the stuff later, so we do it like that. Then we demolish this part and do it like that. And in here we need 8 and a 4. Okay, so let's try to relocate this where it's closer to an 8. Other than that, we are basically only needing a 6, 5s and 4s. 6, 5, 4, 8. Okay, there's some 8s down here. 5s, 4, and 6. We can relocate it over here. Should be okay. Maybe we can do it like this. Does that make it any better? No, not really. It's gonna be a little bit of spaghetti no matter what. So let's do it like this over here. Okay, so first things first, we need the correct amount of 5s and 4s here. So maybe we need some 2s as well. No 2s nearby. Okay, there's a 2 over there. So 5 times 5 is 25, and times 4 is 100. Times 6, where is that 6? There's a 6 down here, we'll take that. Times 6 is 600, and then we need 10. So I guess we take that 2 we looked at. And another set of 5. This should be 6,000, right? We need 3,000. Abort. We need a 3 instead of a 6. Let's take this 3, and it can go over there instead. Or did I math wrong? It's 6,000, right? Yeah, easy 6,000. Clear everything here and everything there. Okay, then we need to make 32, which is 3 times 8. Meaning we reroute these things. Add an 8. Maybe we can use this 4 again instead of stealing another 4 from over here. Probably the wiser choice. Causing a little bit less clutter. Not really, because we're just like cluttering the area over here even more. But yeah, we don't introduce this thing. And we can use that for something else. And this should be 2968. We just have to wait for these numbers to arrive, and then they need to be introduced to the area correctly. And out comes 2968. Woohoo! That was what we wanted. And we also get to upgrade the multiplier speed. Awesome. Okay, then we need to deliver these. Deliver them. And take you over here. Take you down here. And almost in one more down. There we go. Nice. And how are we doing on this? Oh, it's we did unlock a new thing. Now we need to do 1838. 1838. Is that something cool we can do? We could like do it's like 18,000 plus 38. 38 is a weird number to multiply to get to. So maybe we can do like 60 no 6 times 300 and 303. 6 times 303 should be like 1818, and then we add 20. Yeah, then it's just a matter of how do we reasonably get 101, which is not something we can multiply to get. How else can we get? We can get that 606 times 3 is also 1818. 606, same issue, we still need 101 to get there. How can we easily get to this thing? We could also do like 1850 minus 12. That's probably the easier one. Then we just reuse this patent, or maybe even the easier one like this. 1850. That's 50 times 37. Is that it? Yeah, 50 times 37. So 37 is a prime. That's an issue. Let's pull up a calculator on the side here. So 50 times 37, yeah, that's 8050. How else can we can divide by 5, then we divide by 5 more. Whoops. So 74 times 25, or 37 times 20. Yeah, that that makes sense, of course. Are there other numbers that are interesting to try to help us get to 1838? We could try to build that bit builder, where we like just build a binary number generator that will put out any number but really slowly. That's something we could do. We could do like 18 times 10 and just spend some time to make 38. We could just like add stuff together to make 38. We don't have to multiply everything, and it shouldn't be that hard to like add 13, 13, 12. Yeah, it's probably something like that. So that means we take this thing and we put it somewhere around here, I think, and we remove this thing and we replace it with a few iterations of this thing, like that and that. That is horrible, I know, but it will make the job done. So this needs to be 1800, and then we add 12 and 13 together. Where did the 13 goes? Where are the 13s? All the way over there? Oh god, this is gonna be so spaghetti belty, but it's the way. It's the way we went with for this one. And these guys are doing these guys are doing like this, and you can like crisscross a few times. Okay, that's the 38 we add towards the end. Oh, didn't I connect you? That's so annoying. And now we need to make 1800 here. So there's like we add the 6, of course. That's gonna give us the 6. Now we need 300. So we add 3, I guess, giving us the need to get to 100 with the remaining stuff. And getting to 100 with this is like 5522. 5522, yes. So instead of using that lane, maybe you use this lane. And we need these 2s to make 4. And then we need some 5s. Are there any 5s nearby? Yes, there are. These 5s are good boys. And you can come over here and bring us up to here. Also, we could have used 4s and 1s if we really didn't want to make use of the 2s. But yeah, this is... It's not something I'm very proud of, but it should work. And then we just bring them over. Wait, is this the correct number? Yes. And we bring them over next to this line over here, which we know is going into the delivery space where we want it to go. And there was a free spot there. Okay, so now we're making 1838 at least. I hope we didn't wrong math there, but yeah, this looks to be going correctly. Why is it going so slow? Are we just too early in the process that we don't have full belts yet? Yeah, it looks like we still need a little bit higher production of these 90s to spit out 1800s faster. The belts in are going at the correct pace, and there are 20s waiting for additional stuff here. It looks like it's filling up slowly but gradually, though. Yeah, it looks like it's going to come together. It just needs a little time to fill up the entire belt, and now it looks like it probably caught up here. So this should be a full belt delivery from now on. Okay, let's. So I like the chaining together of stuff like this. I think it's nice we made these more compact versions of what we're trying to do, because I think we're just gonna need a lot more multiplication units to get where we need to be going. Okay, we should probably clean up a lot more of the stuff we don't need anymore. Like these 36s, probably don't need them anymore. So let's remove this thing. And yeah, 30. We need 64 to be delivered to this thing. Let's actually utilize this 2 here to make it, and let's learn a little bit more about this exponentiator thing here, because I have a feeling that we could be doing this really easy somehow. So 64 is like if 64 is 4 to the 3, 4 times 4 times 4. So can we find somewhere where there are 3s and 4s close proximity? We probably don't need this 18 thing anymore either. I guess we could use no, never mind. 4s and 3s. So it could, for example, be like 2 to the 2 to the 3. Here is a 4, but we need them even closer, even closer. Here's a 3. Here are 3 and 4. Yeah. Okay. So 4 to the 4 to the 3 should be 64. If I'm not completely mistaken. Yes. So we should just make a factory that spits out any number to the potential they have. Which means we get rid of that stuff, and then we take another line over here and do it like this. No. We need when you're first making this, do it as compact as possible. Why did this happen? Okay, we do this, and then we do this, and then we do that. And now we should have a pretty good way of making large numbers, which is made a lot easier than what we have available to us by other means. But the drawback is I need to be better at math to make proper use of it. But yeah, I really like the idea of having this machine here work. Replace the input data from this thing with the 64s from here, and that should prioritize deliveries from this thing and put it into over here. Yes, they are coming. It's not a full belt yet, so that probably means we need to improve the input rate here. I don't think I want to have it expand the odd just in length. Let's also expand it in girth. So bring this thing over here and do stuff like that, and the force will also go over here, and then we copy that. Also deliver, and then we copy this over to there, over to there, over to there. Remove this part. Maybe this makes a full belt once it's saturated. Not quite. We need just a little bit more juice here. Then we do like that. Just a little bit more juice. And of course, once we finish the first upgrade, it's gonna improve the efficiency by 50%. So yeah, we probably didn't need to worry too much about that speed there. Okay, I think we made a decent chunk of progress here. We improved these designs by adding on these tens plates before we can multiply 4 numbers to make the correct stuff we want it to be. And we made this exponential factory to make stuff exponential. And yeah, it's probably going to be really powerful once we utilize this correctly. Like, what's even 6 to the power of 6? Just to check on that. That might be a really, so it's like this thing here is really powerful at making really large numbers really fast, because 6 to the 6 is like several thousands, maybe even 46,656. So just a simple thing like this can spit out really large numbers, which will help us a lot once we need to hit the sizes of numbers that they are. Maybe that's also just a way to make use of these divisors. We can just like exponentially make something that's really large and divide down to get what we actually want. That might be a thing. And then we're gonna upgrade the belts. Woo! Percentile increase, and then we now need 8,000 stuff to get to the next level. But that's just the challenge of the game. This one seems nice. That's like 80 times 70 times plus 66. We can easily make that with this guy here. So we need like 6, 11, 8, 7, and 10s nearby. Yeah, we're gonna find a good place to make that happen in the next episode. But for now, thanks for watching. This has been Harbinger with some more mathematics, and I'll see you guys in the next one. Take care.